Greetings to all of you who have come for this lecture. I regret that I could not be here today in Ankara. I'm very fond of Turkey, but circumstances intervened that make it necessary for me to send you a video version of my lecture instead. I hope the video will help you to understand some of the topics that I want to talk about, and I hope you will enjoy some of the images that we are presenting. The images are actually a very important part of this discussion. There's an image in the background right now. That is my university. It's the main building. And we're going to switch in just a moment to the slides. I'm talking about managing the integrity of research. And whenever we're talking about information management, integrity is really a key piece of this. We know that if we save information, that we store information, that we make it available to others, there's an expectation that this information is reliable, that we can stand behind it. But we also know over the years, with more and more retractions from academic journals, that we can't always trust exactly what we have stored. The discussion today is about problems we've discovered, is about how to discover some of those problems. So, what is true? This is a very complex philosophical question. I'm not really going to talk about that. But what is trustworthy? And this depends on culture, and not all cultures are alike. So at this point, what I'm really talking about is a particular culture, Western, secular, scientific culture, which has specific standards, and anyone who is writing for scholarly journals in the academic world today must follow those standards in order to get published. That's essential. The background you see here is actually the flyer for the exhibition that will run in our university library, run simultaneously with this lecture, in fact, about how trustworthy data is, about fraud, and about how we measure the integrity of information. The issues here have to do, to a certain extent, with the post-truth world. Post-truth meaning that we don't have an absolute standard. We never did have an absolute standard for truth. What we have are various definitions, and the definition, as I said, that is really essential here is the definition that works for the journals, for a culture that is based on what we call science, natural science, modern scholarship. We have to adhere to these standards if we're going to have an ongoing scientific discourse. And we're going to look at areas here, cases here, where scholars have failed, where there have been falsifications, and in three specific areas. One of those is image manipulation. Images are treated as data. I'll say something more about that in a minute. Data falsification, really making up data. This is nothing new. There's a long history of false information and of false understandings of information. You can have a mathematical representation of how the planets worked. For example, Ptolemy's system, where everything rotated around the Earth. Galileo came up with an alternative, which was mathematically centering the planets around the sun. Simplified some of the mathematics a bit, worked well. It was rejected by the church. It was rejected by many people in the time because it was a change. The other worked. Galileo's, however, worked better, simpler, was more elegant, easier to calculate where the planets were, and that was important for navigation. Later on, as you probably all recall, Einstein, with his theory of relativity, the general theory of relativity actually potentially turned Galileo on its head. Because with general relativity, you could take any body as the measuring point and calculate all other objects around it. That meant that we could go back to Ptolemy and do the math once again, and it was not wrong. We don't do that because the Galilean math with planets going around the Earth works for what we need. Practical results are a very important part of our understanding what we understand in the scientific world as truth, the ability to make things actually happen. Plagiarism is another aspect of that often comes into the integrity issues. Plagiarism is an ethical issue. That's important, though it does less damage to the science that is built on works than does data falsification or image manipulation. And then there's text falsification. We're going to take a look at some of those issues as well. Again, the real key issue here, the thing that we must not forget, is we want to guarantee the reliability of the information we're managing. That is a basic part of management itself. I'm going to give you a larger view of this particular slide. It's a nice picture. It's a very striking picture. And that's something that is very important here. When we publish pictures, one of the goals is that people are drawn into the topic. You take a look at this picture, the Hubble telescope's picture, and you say, creation is happening here. This is really a striking build of a piece of the universe. The colors are enticing, you're drawn into it, and you may be disappointed to discover that it's actually not quite true. This photo is a young cluster of stars in a constellation, Serpens, bright blues and greens swirling together, but it was originally black and white. There wasn't really this set of colors here. We have no doubt NASA and the Jet Propulsion Laboratory actually manipulated these images. Should they have said more about the false coloring? We think probably they should. Scholarly research really demands transparency. And yet this is one of the greatest and largest research facilities in the world. And they didn't really make this clear for most people looking at the image. It's easy to get the impression this is what Hubble actually saw. How is this sort of transformation possible? One of the things that is easy to forget in the modern world is the degree to which we can manipulate photos. Photoshop, GIMP, tools like that are very enabling in terms of how we handle pictures. There's a lot that we could also do with chemical film, with older cameras, with the physical picture, but it was more work. It was a lot more work. And there is a degree to which we can cut and paste, we can manipulate with the digital images that we just never would have done in the past. There are some famous cases of Soviet-era photos where suddenly someone who was out of favor wasn't there anymore. We could, in a previous era, do that. Today, it's easy. And these tools were not built to be falsification tools. They were built to help us clarify things, adjust pictures. There are good and legitimate reasons for doing this. One of my doctoral students did an interesting set of interviews with a professor in biology who said when Photoshop first came out, she, of course, used it to clean things up. She wasn't falsifying, but there was a scratch on the slide. She'd take out the scratch. There are legitimate reasons for intervention. People also sometimes, as we see with the Hubble picture, want to make it more visible, want to make the events, the images more striking so that people will look at it, will see certain things there. As long as you say that, as long as you make that clear, it's not necessarily illegitimate. It's a tool for understanding, a tool for conveying. So let's think about two aspects here. One is a picture is a picture is a form of data. We take it as truth. It's not completely truth, but we take it as such, and it becomes a piece of evidence. So we look at this picture and say, this is a creation of the world. It's not so much different, really, if it's only black and white. But our emotional reaction to that is different. When we're dealing with digital images, people sometimes talk about originals. And what is the original here? An original in any digital camera is the set of light, the photons coming into the camera, striking an array, and that array sends signals. Some higher-end cameras are capable of taking raw data in, which means it's really taking in the information about the light signal, and that information can be manipulated in a very broad range of ways. We can take that into Photoshop, we can take it into GIMP, we can create a picture that is, to all test aspects, an original, but we've manipulated it. So we've got power to make a piece of a picture that we wouldn't normally see visible, or power to make it invisible, also depending on the light settings, also depending on how we crop. What's happening here in this particular picture from NASA is not fundamentally a falsification. It's an attempt to make people see things that weren't really there. It's an attempt to draw people in. The next picture is considerably more complicated. It's a set of slides from a laboratory, and you really need to have a level of expertise to understand what's going on in these slides. These images actually had a political history as well. They were used as a reference for in the Italian Senate for opposition to genetically modified food. And however you feel about the genetically modified food, the argument was that it could have an impact on the offspring of goats that ate the soybeans, had political significance. One of the Italian senators, who was a neuroscientist, looked more closely at these pictures and said, actually, there's manipulation here. There's some things that have been changed here. That's also very easy to do with these kinds of images. Typically, they come out of a slide from a camera in JPEG form. We put them into a tool like Photoshop, and we can do a lot of things with that. Cut and paste, drop some things out, change colors, that really change the content of this. The person who headed this research team was not only accused of self-plagiarism, which we'll talk about later, but about erasing elements, duplicating elements, and the effect was to undermine the value of this. The paper was retracted and had further political implications also within the Italian Senate, people being accused of being lobbyists. The effect of these manipulations can't be overstated. You're taking evidence, you're taking data, you're taking things that people believe are facts and falsifying them. An image is powerful because it's generally believed. Let's go on to another topic here, and this is data falsification. And there's a big range of data falsification. I'm going to give you an example, a really very widely known example of one of the most extreme. Dietrich Stapel was a social psychologist and very successful. He created a set of experiments that were elegant. In this scene, and this scene is a drawing by Dr. Thorsten Beck, who's one of the staff of the Head Center, to reproduce the situation here. Stapel argued that untidy surroundings trigger racist behavior. It seems plausible enough. He set his study in a train station in Utrecht, in the Netherlands, but he was a little sloppy. He didn't adjust his descriptions of the site of this experiment for the actual numbers of seats, the actual detail there. And there came a point where some of his graduate students became suspicious. Stapel had been a really successful researcher in his earlier life, very highly regarded because he did excellent work. One of the things he began to realize, as he has said himself, is editors don't want messy data. Editors want an elegant story, something that is convincing, something where they can publish it and say, look, here's a result, a clean result, a result that is so powerful you can't not believe it. And most real-world data isn't that clean, isn't that simple. But if you make it up, it can be. These graduate students, these very brave graduate students, voiced concerns to the department leadership, and the whole set of fabrications began to unravel. 60 of his publications were retracted. He lost his job, his doctoral degree. One of the most dangerous things that happened here was that he gave his data also to his doctoral students. Some of them wrote theses based on false data. The universities managed to handle this in a way that did not harm the doctoral students, but longer term, this undermines the confidence that people have in research in very fundamental ways. His argument that editors wanted some cleaner, better, simpler results is something that anyone who has written for academic publications can understand. It's something that anyone who has been an editor, and I was an editor for 20 years, actually I still am an editor of some journals, can also understand, because we want that cleanness, we want that degree to which content is just absolutely overwhelmingly convincing, but it can also be false. Let's move on to an interestingly complex story again. And this is different because it's less clear-cut. Again, a psychology professor, someone who was at Harvard, Mark Heuser, claimed that tamarin monkeys would react to alternating music patterns. The idea, we are related in some sense to monkeys, and one of the research themes that has been ongoing for a long time is the degree to which the things that we as humans would react to can be reproduced in the world of primates. Trying to understand how they're thinking, whether it works, whether this makes a difference. And so he set up an experiment. Again, you can see a drawing by Dr. Thorsten Beck about the setup. There were music coming from a couple of different places. And he argued, Heuser argued, the monkeys were reacting to the music, to changes in the music. There were people who were skeptical, not surprising, and a research assistant who was asked to examine the video research of the tamarins, this was all recorded, there was data there, didn't agree with with Heuser's argument that the monkeys were reacting. It raised more suspicions, and a Harvard report of the case decided that Heuser had skewed his analysis and had misrepresented the results. They also claimed that he had fabricated data. He'd already resigned his position from Harvard, admits to some mistakes, but not to misconduct per se. I'm not saying there was misconduct here, or that there wasn't. What we want to do is take a look at these very complex examples where how we interpret what a monkey is doing, how we interpret a video, how we shape the data from that video, these are all factors in whether an argument is convincing, whether a situation is going to be such that the people who read the article will say, yes, of course, that's what really happened. A real problem is the real world is often messy. Did the tamarins react? Did they not react? There is a degree to which that could be personal opinion. We must also realize that he wanted them to react. He wanted to believe it. And this kind of prejudice, this kind of assumption built into the part of the researcher often skews data. He saw a reaction because he expected it. He wanted it. Maybe the doctoral students, the research assistants, were skeptical at the beginning and therefore didn't see it. We don't have all the details here, but we know that there was enough complication here, enough doubt here, that the university took some fairly serious action. Let's look at another case, and this is a case, once again, where we're not really necessarily talking about someone who has done something wrong, who's done something false. We're talking about a level of contamination, the discovery of contamination, and what we can really do. So in this case, some misidentified cells became a form of contamination. This goes back a long time, 1966. A professor at the University of Washington proclaimed that cells he were working with appeared to be contaminated. Long time ago, 66. More recently, 2015, another researcher, Christopher Koch, looked into the issue and concluded that a very large number, 5,800 articles in 1,182 journals may have confused one type of cell for another. Contamination is something that happens in laboratories. Anyone who has worked in a laboratory setting knows how very important sterility is, cleanliness is, how very easy it is to get some small level of contamination in. There's no reason to think that the scientists actually deliberately misidentified the cells. But once the misidentification happens, the problem spreads. These samples are a form of living data. People share them. People expect certain sets of results coming from them. And how we really warn people about potential contamination, about this kind of effect, is a real challenge for the academic world. We need to be aware of it. Contamination especially is something where all we can really effectively do in a laboratory setting is make people aware this could happen. You may be looking at something that is very similar, but is a different kind of cell. If you've looked through microscopes, if you've used the tools that biologists use, you'll realize it's actually a part of the training, a part of what makes the work challenging and difficult is to separate sometimes one cell from another, one type from another. We're coming up now on plagiarism. And plagiarism is a very broadly discussed topic. It's one of the topics that gets most into papers about research integrity. It is one of the topics that particularly fuels the warnings at universities about integrity problems. Most major universities, especially US universities, but British as well, have websites explaining to people why they can't plagiarize, they mustn't plagiarize, how to avoid plagiarism. They try to explain where you are paraphrasing versus where you are plagiarizing. And one of the things we need to realize here is that the line between paraphrasing and plagiarism is much less clear today than it is often expected to be, than some people believe it is. 20 years ago, maybe 40 years ago, when I was a doctoral student, it was not uncommon for a major professor to say, such and such said somewhere that. A form of citation, but a citation with maybe a name, but without necessarily having the page reference. In talking about the literature of a field, we use the same words, the same phrases that are used in other works, other journals, other books. The more deeply you are in a particular subject, the more danger there is. There is some concern. Concern has been expressed that people who have very good memories, verbal memories, visual memories, tend more to have this problem because these phrases have become incorporated in how they speak. In fact, how we speak is very much influenced by what we read, what we hear. We pick up the phrases of our professors. We pick up the phrases that we hear in conferences. You may pick up a phrase or two here. I hope you do, actually. That isn't plagiarism, but the standards have changed. One of the standards, and you can see it here, is an analysis by a group that works in Germany, in Berlin, taking a look at publications, mostly dissertations, that they can analyze and say, okay, this phrase is so close, uses so many words that are similar to that phrase from this other work that they think it's plagiarism. Obviously, the original authors didn't, or at least we think they didn't. There are some cases where the amount of matching, the amount of text that is taken is so gross that it's hard not to think that it was intentional. What we have in this picture is a barcode that is giving some indication of how much has been taken. As you can see, the blue are pages that are not affected. Black means some sites that the people who run Ronnyplug believe are problems. Dark red, 50% or more, and red over 75%. So they're giving you various amounts. They have their own standards. They have high standards. And they do a calculation about how many pages were found that had matches, and the percentage of pages with matches within the whole work. The barcode graphic is enormously effective in persuading commissions on integrity, also university commissions that are set up to review problems, that something is wrong. All those pages, all those marks, but it doesn't necessarily convey a balanced view. Because when you do a calculation based on the colors, it's not every one of those colors actually represents a whole page of problem. Sometimes it's a few lines, sometimes a few words. And there are cases, not ones from Ronnyplug necessarily, but there are cases where perfectly standard phrases are used and yet are called plagiarism. My favorite example, and I'm not going to give the source, this was a case that came to me in my role as chair of our Commission on Research Integrity, is a case where a person was accused of plagiarizing a phrase which goes roughly, Mecklenburg-Vorpommern is a state in the Federal Republic of Germany in the northeast. And there's no doubt, many people have said this. It's a fact. When we're dealing with facts, we're going to get a lot more overlap in what people have said than if we're dealing with something that is new and unique. There are also long chemical names, there are processes. In statistics, there are certain ways that you say, this is actually the result of a statistical analysis. That's not plagiarizing, it's using the vocabulary of the field. Most fields, most technical fields, have a significant amount of technical vocabulary that needs to be taken into consideration when using these kinds of plagiarism analyses. Ronnyplug uses a variety of sources, some mechanical, that is, some computer-driven, but they do check by hand. And there are some excellent tools, Turnitin, Authenticate, that will also do matching algorithms. A number of universities use them. Again, particularly in the Anglo-American world, use them. And what they do is they check the language of a paper against the language in a database and say, okay, this is similar, this is similar, this is similar. They'll flag those matches. Then someone has to go through and see, are those actually cases where something serious has been copied? Are those cases where we need to worry? Or is it chance? Is it an overlap of facts? Is it an overlap of standard phrases? With these tools, you can control how long the phrase is. You can make a set of intelligent choices. You can get a lot of false positives with these tools if you don't know how you're using them. And this is one of the things that drives a whole set of costs for universities, is that when we have a tool like this, we have to have someone who knows how to interpret these results, to know when there's a false positive, know also when there might be a false negative in something that further checking is needed. Some universities, again, I won't name them, but some in Britain have come up with a good solution, I think, which is to have students send their own papers through Turnitin, and if they're getting false positives, it's a signal to them they should correct it, so that what finally is turned in has to have a low percentage of what Turnitin sees as an overlap. It's a self-correcting mechanism. I want also to persuade you, and this is an important thing to realize, plagiarism is important. Plagiarism is an ethical violation. But plagiarism is much less serious, does much less damage to scholarship than data falsification or image manipulation. Because plagiarism is not faking the truth. It is not faking the data. It is a form of stealing, yes, taking from someone else, but that doesn't falsify the record, unless people are taking the information from some source that is already falsified. The issue here with self-plagiarism actually grows out of a broader problem that many universities look at citation rates as factors in promotion, in hiring, in giving salary increases. And this inspires people, perhaps more than it should, to create references to themselves. It also is a temptation that anyone who has done very much writing over the years will know, to reuse content. In this case, a Cornell University professor and former editor of a journal was accused of self-plagiarism because of a very high number of self-citations. It certainly improved his citation rates, but it got to a point where it was so overwhelming that it had a negative reaction. One of the most alarming examples was an article written by him that was 95% taken from two of his own works. He just took two works, put them together in a third, and counted that as a new publication. Theoretically, this could be a breach of copyright because most authors actually end up giving their copyright to journal publications, so there could be some legal implications. Mostly, it is, however, an ethical matter. It's an attempt to manipulate people's opinion about how productive someone has been. Predatory journals is a new topic. Predatory journals essentially did not exist in the pre-digital world. Essentially because it cost a lot to publish an article. There were vanity presses you may have heard of. These are publishers where you pay the publisher and that publisher will produce your work. Mostly people don't use those if they are scholars. People will use them sometimes for novels. The funding source to make the publication happen is the author, not the audience. With academic journals, it has long been the case, going back in hundreds of years, that it's the people who are interested in reading the content who carry the costs, the people who buy the journal, who buy the newspaper. In the digital world, as we have thought more and more about open access issues and look for mechanisms to enable open access, definitely a good thing, but it costs money. Publication is not free. And to have a revenue source for that, one of the solutions was gold open access. Meaning, if your article is accepted, then you, the author, pay for the publication costs, probably from grants you've received. And anyone can read it, completely open at that point. It shifts the burden. It means many of these funding agencies, in Germany, the DFG, in the United States, for example, National Science Foundation, are willing to include money in grants for the publication of results. All this is positive. But it also means you get journals starting up where they don't really follow the academic standards, where they are really just making an effort to get that money. They will do a completely pro forma review and then want to go ahead and give you a bill and publish the results. One of the best of the German newspapers, the Süddeutsche Zeitung, the South German newspaper, did an experiment where they created a fake paper, sent it in under a name that's equivalent in English to a person named Imaginary, and it was accepted with no obvious base whatsoever, and they asked for 1,892 euro for publication fee. Obviously a problem. There are a lot of plagiatory journals out there. We don't know exactly what all they are. Beale's list is an important source of information, but they evolve. Some start as predatory journals and have moved on to being more serious as well. So the old list is not completely reliable. For new scholars who don't know the world, who not necessarily get publication in the best journals, this is a real risk. Detection is something that is important. Detection, I mentioned already, with plagiarism is not so hard. We have tools that do that. We're trying to put together a database tool, image database, so that people can use that as a base for developing tools that will do an automated analysis of an image to see whether it has been manipulated or not, whether there has been some form of cut and paste, something cut out. We know to a certain extent how to do this. What we really require at this point is enough of a set of images to build tools that will be reliable across a broad spectrum. This is an ongoing project, and you will see more about this in the future. Plagiarism detection is, I said, a difficult area because we need to treat people fairly. And in one of my books, Quantifying Research Integrity, I propose a scale that gives you not just black or white, this is plagiarism, that isn't plagiarism, but a grayscale analysis. You can say, okay, here are some problems. Here are more serious problems, depending on how many words, how many sentences, what the context is. We need to look at these issues in a sophisticated way that is not just saying good or bad. That is itself a scientific issue. We're almost at the end here. Replication is important. There have been a number of replication studies, and those studies show clearly how difficult it is, especially in any kind of circumstance where humans are involved, because you add a lot more variables. If you're dealing with physics, if you're dealing with chemistry, you've got a fairly clear set of results and a fairly clear replicability. In biology, in medicine, in any of the social sciences, you're dealing with so many more variables that an actual replication can be hard. And yet we recognize this is perhaps the best tool we've got to say, is this true or isn't it? Information management today, we're not just talking about sorting. We're not just talking about classifying or providing access. We really need to test that the information that we are providing for people itself is reliable, and we need to take it out, to retract it, to label it at the very least if it's not credible. I will just give you a set of references here. I think this is important when you're talking about any kind of research integrity. Most of these come from the exhibition text. Here are references from the talk itself. And here are the image references, which you could also follow up if you wanted to. That's what I have to say. I hope this video keynote lecture was of interest to you. Again, I'm very sorry I could not be there. I'm very sorry I can't be there, especially to enjoy the lovely Turkish food. But I wish you a happy and successful conference. Have a good day.